Hi all! Today I want to speak about a topic I didn't work on for a longer time, and it's about real car scans. And I'm not talking about the small cars, I'm talking about the big ones. So we had this living here near Stuttgart in our very first years of our business quite a lot. So there is Porsche, there's Mercedes-Benz around here, Bosch, you name it, all the companies who are well known over the world for cars. And of course we had some contact and we had projects. So it was in 2012, it was really demanding to find a scanner for scanning whole cars, hand scanners that are flexible, payable and precise enough to create a reasonable project quality that you can work on. And since then a lot of things have changed, and that's, I think, a good point to make an update as well, to explain you some tricks and ways how we are doing car scans of big car surfaces. And I had two recent customer projects I want to use to explain you a little bit about some background, how you can make it better. And this is as well a point where I came really to that situation where I really like to work with an FreeScan U11. So even with its not so cheap price, it's not priced like an EinScan HX, it's maybe the best scanner price to benefit for car scans. And why is it like that? It's a laser scanner, so not like with the white light scanners. You need no big spraying or stuff. You can scan more or less all the surfaces on the car with just adjusting the parameters of the scanner. You have magnetic markers, so markers will make your scan a lot more precise. In the early years the scans were really unprecise because you had a big error accumulation along the scanning distance that you had from the back to the front. It had been centimeters or millimeters, and you had to find a way to deal with that. And the really gorgeous global preciseness of an FreeScan UE of 0.02 on 1 meter makes it really possible with a hand scanner in very short time to make a perfect scan in professional quality that you can use to build your customized body kits and so on. And compared to the cheaper scanners, he has that really great global preciseness. And compared to the more expensive scanners as well from other brands that can be laser scanners as well, it is cheaper than most of them and priced in a similar area. He is fast enough, he has a really big scanning field, a really good resolution, that's good enough for that by far. And you have really as well some quite performing software that can handle big surfaces. So I really start to like that. I was in the beginning really thinking, is it so intelligent to launch another 3D laser scanner from Shining in such a short time after the success of an EinScan HX? And I got to say, in the car scans I found really the benefit of a FreeScan UE. And we as well sell them right now because we see that it's a really good product, and we just sell products that we believe in. So go to our shop, find as well from time to time used scanners, find their new scanners, the right laptops, equipment and so on. So you would as well help us to create new content and finance ourselves. But I don't want to make a really, let's say, sales propaganda video. I will make a video based on how to scan cars with a hand scanner, and it will be more general. So it will be as well possible to use that tricks for other brands like CG, or you can use EinScan, other, let's say, scanners like the HX or an H, an Arctic Eva, an Arctic Leo. It will be more generalized tricks. And take a look. Along the way you will understand maybe why I start to like the product. And we will maybe as well make more videos on car scans with special topics, but this will be for the next episodes. This shouldn't be too long, and I just want right now to keep the focus on body scans that are made for, let's say, design additional parts, custom parts, styling parts at least. And yeah, take a look, maybe you like it.
So I was asked many times, what is the right strategy to scan bigger objects? And especially in cars, it's some topic. When you're using hand scanners, you have normally a rather poor global preciseness. That means along the scanway that you are doing on the object that I will sketch here with this tool, you are losing preciseness because the positioning errors will continue to sum up. So you will have here some tendency in the width of your scan field along the way to have errors in up and down direction, and they will sum up. So if you will start, for example, in this direction, and you will come here to this point starting next scan from down there, you might have really big differences in these areas where they connect. Such big differences that you will not have a good merging scan, or you will create gaps, or you will create mesh problems, whatever. So you don't want it. If you have to scan a whole car, my recommendation is starting from the top. I can just use the standard orientation. I don't have to make it more complicated. Imagine of the ways that you scan down to the end of the object, and try to find a center point where you have more or less estimately the least length to be done down the way to your end. That means as longer the way from your scan start point, the more deviation you will create. For example, you start here in the roof, you're going down there, you're going down there, you're going down to the back of the car. You will have always the less possible deviation in global preciseness possible, because you are minimizing the overall error by the fact that you are not going a long way on your surface. For example, if you would try in opposite to go on the car from here to there, you will have from the back to the end of the car a really big deviation, because the errors in alignment of the scans are going over the different views of your scan field to sum up. So if you're going this way, for example, the deviation between back and front, or front and back in this case, will be really big relatively to each other, because you will, let's say, have a long distance and the global error will sum up. This is really some kind of a problem that can lead to what I show you later on in an example that we received from a customer that had really big problems to create a scan. Okay, so let's clear it up. If you're doing a half scan of a car, because as explained in this example later on, cars are symmetrically designed, most of the cars, and this saves you a lot of time not to scan the whole car. You would just scan a half of the car. If this is your aim, if you want to go this way, what totally makes sense, the end in the middle will be the plane that is the, in this case, YZ plane. So the center point start to scan is with the less sum of all lengths from the ways you have to go, is somewhere in the projection of the scan. Imagine it's like a lemon. You smash it on the floor and you are standing on it with your foot, and what rests is more or less the projection of your surface, and the middle point of that is where you start to scan, and it's the same for the car. If you would try to project that surface of the result in your mind on some flat surface, the middle point, the center of gravity, will be this point more or less. It's just a good estimation. It's not, let's say, some really strict rule. And you start to do your ways, scanning down from the center to the different areas. And of course you will have to go back a little bit and use these areas to fill that up, that space. You will be fine. This is just the center of your scanner way, your path on the surface that you will do. So just keep that in mind. That is, this is really different doing a half car scan or a full car scan. In the case of the FreeScan UE, and it was really good enough to do it without respecting these rules. With an HX, an EinScan HX, you will have much less problems, let's say, keeping this advice. Just to give it a final example, I think you got it so far. If you want to scan just the bumper, it can be the rear bumper in this case, and your borders of the scanned areas are the bumper itself. So imagine where is that smashed center of gravity that you start from, where you have the sum minimized more or less to the edges of your scan. So you start somewhere in here. This is, imagine this is center of gravity. If you would put a bumper on a pin to balance it out, it's more or less this point actually. Or actually it's this point, it's the same rule that follows it up. And you would scan there to these areas in these ways. It's more important even if you start to use different project groups. If you do it in one scan, it's not such a big problem. You can, let's say, intermediate that somehow, but if you start to work with different project groups, try to keep estimately these ways on your path. Go here, go there, and so on. So I really recommend to keep that strategy. It will make scans, for example, with an Arctic EVA or with an EinScan HX or an EinScan H or so, will make them much easier. So this is a project that I received in a customer discussion. There was a company tried to design some stuff based on the outer shape of an MAN TGA small truck, and he did really have problems to create a result out of this what he scanned, and you will really fast understand why this is really problematic and in this case directly impossible. So first of all, look at this amazing amount of triangles. It's 143 million triangles. So this is a huge motor. I was then going to look into the configuration file of the scan. This was done all with an EinScan HX. Pretty amazing that it was possible to come so far, but actually this is where he got stuck, and this is quite clear why. First of all, the resolution that was taken for the overall body kit scanning was 0.3, what is far too high for the whole, let's say, cabin of this truck. So this is equivalent to a smart 4.4 or something, a small car like an Opel Corsa or something. It's equivalent because that cabin is not so small, and this is really a huge mesh actually. And not starting to plan the path for the scans, doing scanning with the hand scanner, it creates additional problems. I will just, let's say, unshow some bigger parts, because as you can see, this model really stresses out my GPU unit. It's an RTX 2070, and this is not at least the worst that you can have inside a notebook. You as well will hear it by the environmental sound that my PC is doing here. And let's see where it is possible to see that in a good way, but maybe I think the easiest way will be the connection. So what happened actually? Somebody tried to scan the car, and he did it by I will try to brush the way how this was done. You can as well see that by the numbers for the scans. Okay. So the path was done scanning around here. There was another scan implemented here. Here was, let's say, a new project group. You've seen that when I was dividing it up. He went around this part, the bumper and so on. It's just a roughly show. And went back up. On the other side, you see that by the scans numbers, and he was then afterwards sketching around here a little bit, came back and tried to close the scan on the roof. So there was created a problem that I explained already. You are along the way creating a global preciseness error problem. That means if you are scanning on your path, you are losing preciseness from one point to the other point in a global coordinate system, and this leads to the point where the scans itself can be quite precise, but you will see in some areas that the same markers are not matching perfectly together. So here you can see it. This is the same markers position, but of the fact that you have so many paths on that truck cabin that come together to one point that are unstructured, you have here some worst case scenario of superpositioning, and you have here deviations that will be in around about 2-3 millimeters of magnitude for the same points, and this will be, by the fact that it's far too big, quite sure not be merging fine, because you are coming into the point where there is a gap between scans that are aligned over the markers that was used. And if you will start right now the calculation of the mesh, you will come into some memory error. That here in this case I'm using 64 gigabytes of RAM, 8 gigabyte graphic card, and I have plenty of SSD memory, so imagine this is not a topic of your PC. This is some internal limit from the software. We tested it as well on a PC with 128 gigabytes of RAM. It was not possible to calculate that mesh. So this is just a way how you shouldn't do it. In this case, I will explain based on the model from that AMG GT Mercedes-Benz, what is strategies that you could have used, beside the fact that you shouldn't go so detailed in the scans. If you are scanning here with a resolution of 0.7 or so with an EinScan HX, this will create a far more handleable data size. And imagine that going from 0.3 resolution to 0.6 resolution is just half the amount of triangles and data size, and this will bring down your calculation times and your problem by far. So you should be able to do that with an HX in the original software. It's possible. I did these scans in similar size as well, Unfortunately, I'm not able to share the data because this was done with a customer that has some, let's say, confidential project. But you can see what will happen in this case. I was able to reconstruct that model later on by exporting the scans in reduced size to Geomagic Essentials and merge it there. So you will be able to make it. It's not, if it happens like this or you are on this point stuck, you can do it. There is a way, but it takes you a lot more time, and it's overall, let's say, not so efficient, because you have spent a lot of time putting markers on a cabin that maybe a symmetric scan, that means a half-side scan, would have been enough. Spraying and so on wasn't necessary, but overall it was for sure a huge amount of time invested and a lot of trouble that it cost. So here you can see the scan raw data that was created to get the AMG GT right, and what you see is that this is just half of a car, and this is absolutely fine for designing body kits and bumpers and so on, because these cars, like most of the cars for personal transport as well as sports cars, are symmetrically designed. So you can just mirror the car to its symmetry plane in the middle and you will get a complete carrossery. It's of course not exactly the same like scanning the car in one piece, because you will have, for example, here writings about the type and motor that will be mirrored as well, and as you know, mirrored letters are of course not shown in the right way, so this is just something to be regarded, and this is not a topic for body kit design, but if you need, for example, a whole representation for rendering or for texturing, whatever, you will have to scan really the whole car. So you will see already that this is a really big piece of a scan, and this is just one scan only. So with the UX11 it's possible to get a really huge surface scanned in a good quality because of its exceptional geometric preciseness over global surfaces. So that error summing that you will have in each scan will be really minimum, and this is outstanding as well compared to other brands. Before we continue to process this data set, I'm going to clean up the things that I don't need. For example, I don't need the wheels. So this will be fine so far. I'm going to use Geomagic Essentials to post-process that scan. So I'm not going to continue to clean it up further. I will do that in Geomagic because the tools are a bit more versatile and I can easily select some things and clean it up. What I just deleted is to reduce the calculation time a little bit for things that I will be sure that I will not need them. So as the scan was done in a resolution of 0.5, you would imagine a really long calculation time, but take a look at the watch down and you will see that this will be ready in something about 10 minutes, what is really gorgeous for a scan in 0.5 of that size, and this is really fast. I'm going to calculate it of course unwatertight because I'm going to clean it up and mirror it before I want to have a watertight model. I leave the parameters quite in standard because of mesh size and everything. It will be fine, and keep calculating. And look at that, we really calculated a mesh of 19 million triangles
in a few minutes. If this isn't gorgeous, I don't know. So as I already mentioned, I want to continue post-processing in GeoMagick. I will not use the functions here. Actually, I opened that scan in the HX software from the UE, what was possible with the first versions of the scans. And I have the big benefit that I don't need that dongle with me. That for me is a bit annoying. So here we are, model is open. I am asked if I want to use the mesh doctor to repair mesh errors. I think I will not need it now because I will change quite a lot on the mesh and the mesh quality, and I will keep that for later on. So you see the open borders of the scan, and the first thing is I will check. Oh, it's still quite the same amount of polys, how big the size is, so I didn't really reduce a lot. So I will start to decimate, and I really like the possibility to choose the decimation amount by the tolerance that is allowed. That means I can allow some difference that I accept between the mesh that we have right now with the high poly degree and the mesh that will be resulting by reduction of polys. And I think this is a really good way to stay in some defined preciseness. As we scan with 0.5, reduction tolerance allowed of 0.1 will not harm me too much in my work. It will not really create some big difference that is relevant for cut design. So let's see how far we can reduce the mesh, allowing difference of 0.1. And I would say, wow, this is really a big amount of reduction in triangles. We went down from 19 million to 4 million, and let's see how the representation looks like of the result. And I would say it's really still great. I have really still the writing details from the motor type and so on. So next step to be able to work with the model properly is for me an alignment to our wealth coordinate system that makes sense for further operations like cutting or mirroring. So I have here a problem, so I should find some features on the surface of this mesh that are perpendicular and have some meaning regarding the orientation of the car on the street. And this is rather difficult because as you can see, there is nearly no flat surface and perpendicular surface on this car. It's a totally aerodynamic shaped style, and it's not easy. So fortunately we have a Mercedes-Benz here. Why do I say that? You will see that now, because the brand's symbol is really good to create a surface that is symmetrical and perpendicular to the road surface or the road representing surface orientation. So I'm going to create a middle plane by just simply using the brand symbol. I pick up 3 points, assuming that they are more or less in the middle. Of course, you have some uncertainty here, but the whole bodywork isn't like shaped in the preciseness of microns, so it should be approximately fine. As well, we will be in the mirroring process be able to align through superposition of the meshes by best fit, so this will not play any role anymore. I say okay. This should be representing some symmetry plane. I will have to first accept it and then say okay. And I see here was created a plane that looks quite promising to me. I just need that plane bigger. I can go here to edit features and I can resize that. I just want to have it big enough that it's outstanding of the shape from the car. So maybe I'm going to say something about 4. So here we are. So the plane is in each orientation right now bigger than the mesh that we have. That should be fine for our case. Let's see how it is in the front. Yes, that's absolutely fine. So I can already vertically orientate the car. I just don't have any information regarding the orientation, but I will assume that this fins will be positioned parallel to the street, and I will create some orientation line to use them to orientate the car. As well, this is not a problem if it's not 100% perfect, because I will have to readjust it maybe in the second step before starting cut design, but it will help me out to continue the next operations. So we should be ready for orientation. To do so, I have in tools is the English version for that, orientation to world coordinate system, and I can pair right now my created features, for example with global features. I didn't create any additional ones, so global features are fine. And I actually want to have it that the roof is going to Z direction, so I will do a pair of what was created. Have to change the orientation. So this looks better to me. I will choose this orientation, say OK. So you will start right now to see why it is so beneficial. I can just use the standard orientations that I have here for surfaces and so on. So you can just go there, get standard orientations and start to work with them. Doesn't matter, it's like just really beneficial to have a clear orientated car, and you will see right now why. So I will start to first cut what I don't need of this car. So I'm going to use a right angle, and I will have to be sure that my selection is parameterized in the right way. So I want to select through, because I don't want to keep parts of the mesh. And I'm just going to select the part I want to cut away first. I say OK, cut. And I'm just ensuring that there is some overlapping to the geometry line. You will see that later on why. This is very important in the alignment of the mirrored
mesh that you will create to be sure that they have enough surface overlapping information to have a good alignment. If you will cut it really in the center, it can happen that you have no information coming from one surface to the other that can be used in best fit, that will be giving a good orientation. So keep a little more of the scan, and you can cut it away later on, and this is making sense as well, but this is not for now. So I just cleaned up first part of the mesh. I could start to fill holes now. I think this is a good time to do so. I'm just going to fill small holes first. I can just see what will be filled up by going to some kind of preview mode. So somehow the software seems to be staying busy. I'm not sure if this is some problem or not. I just will leave the function by closing the holes that I already pre-selected. So first I will be fine. What I could do right now to continue to work fine, I could just give it a try on the Mesh Doctor, because I was changing the mesh quite a lot already. So to see that there is no big invertations and so on. So I'm going to choose Mesh Doctor and make an analysis of the mesh quality. So let's see if we will have to face major problems by repairing that. So you may be using Geomagic Essentials already, but some of you don't even know that. You will have to run that process of Mesh Doctor many times. So you will run it, and in the best case, all the values of mistakes that you have here as summary, they will be reduced to 0. If it's in this stadium of the scan, work isn't coming down to 0 exactly, it's not a big deal. You just have a better mesh quality to continue to work, and you will not mirror, for example, tunnels or big spikes. So run it 4 to 5 times. If there is nothing changing anymore, you just could go on and later on search for errors that you have to correct manually by, for example, deleting mesh or remeshing and so on. But this is a good way for an intermediate quality checkup and continue to work with better mesh quality so far. So we should be fine so far. We have received a really huge reduction of errors, and for continuing to work on this basis, I'm absolutely fine. So let's commit with OK. After running it for about 4 to 5 times, we are fine for continuing to work. For guys who are using rep, you can use the script function and write yourself a script of rerunning it 4 to 5 times on one click. Unfortunately, this function wasn't implemented in Geomagic Essentials, but it's not a big deal if you're doing it from time to time. And yes, about holes filling and next steps, I'm going to first mirror the car before I will start holes filling, because I will try to use more automated functions and I don't want to run them too many times, or as well I don't need it for mirroring so far. What I see is that there could be independent pieces of the mesh that are not connected to each other. That's like a little bit of problem. It can lead to inverted surface normals in the mirroring process. That's something I experienced in the past. So I'm just going to fill up the areas I'm not sure if and how they are connected. So I think this is time for mirroring the car. To mirror that created mesh, you are just selecting the mesh and say copy. You will automatically receive a copy, but this copy will be of course identical to what you already have, and they will be superpositioned so you don't even see them. In the case, I will just start to rename it according to its size, and this is left. And this is right. And to continue, I will have to align, or first mirror that and then align it. So there should be under tools the option to mirror, and I should be able to select the plane. As the whole scan is aligned quite well to my world coordinate system, I just can say I use the world coordinate system, and I'm just using my YZ axis and say do so. So we should have received right now a mirrored car. What is important, what I did wrong in this moment, I can maybe escape with escape. I just didn't activate turn only, because in this case you don't use this function. It will happen that you will receive a mesh that will be one mesh containing left and right side as a result. So I just want to turn only the copy that I created on the mesh. So it should be better now. And this looks quite promising to me. What is next is I will have to superposition them. For this I go to scan. It's like superpositioning two scans that you did, nothing really different. And therefore you can use the registration. Of course you will have to select more than one scan. You will not be able to do so in the case. First I will have to manually pre-register the scans. You cannot do global registration first. I will select one as fixed and one as movable. In this case it actually doesn't matter. Pre-alignment will be done just by 3 points. That's the endpoint option. You can try to do it with the 1 point option, but I'm not expecting that this will lead to good results, because that is not really a 100% symmetric geometry. It's near, but it's not perfect. So as well I will use again that features that I used before for starting, because I think they are quite easy to find and they are quite strong for alignment uses. Okay, select 3 points. Actually approximately is enough, you don't have to do it too accurate. This is fine. And you can see the pre-result, that looks quite promising. Okay, I would say about this nothing really to do, so I will say okay. And what you might realize is you have here parts of the mesh. In the case of merging the scan, they have overlapping, and it might be overlapping to the negative and the positive. If I highlight one of the scans, you can see they are going through each other because of the best fit alignment, and we can merge that later on just to see what the problems are that you will have to expect if you keep it like it is. It was very fine to align it to register all that right so far. Globally register, of course. I can give it here some tolerance. Say OK. Accept. So from the alignment side we should be fine. If you want to merge them together, you should use merge unification, whatever will be the translation. This keeps not both meshes that you did. It will just, in superpositioning overlapping areas like this one, it will unite them to one mesh, so you will not have multi-layer mesh. That will be the case of this button, so don't use it. I will just save it to be able to go back in any case that it will not be possible, and give it a try how it will look like. I'm using here different to the default. I'm using maximum noise reduction. Global registration I'm using 0.001, and I'm not going to delete the old data. That means that two meshes I use for the mirroring, they will stay. So here we are actually, and it turned out far better than I was expecting it. You see that there was really not such a big overlapping area realized because of the maximum filter that I put. Most of the times it can be necessary that you go back and in this positioned status of the scan, cut this overlapping area to be smaller. This will avoid that you will have overlapping interference in the mesh. Actually, the quality of the scan seems to be so well that in a standard quality you don't have to do that measure. I was doing that with older scanners. With the UV it seems to be absolutely fine. So let's stay like this. Check the result for mirroring interference results. Here you can see them. So maybe it's still making sense to clean it up. So if you have some residuals like that and they are just regionally, it can make sense to just repair them instead of try to do the process again. And that's one of the reasons why I really like to do this stuff with Geomagic. They are really having cool tools for this kind of the stuff. I will show you one that you will really be amazing for you using that stuff. So we are just activating the result mesh so we are able to work on, and I will just select that area. Okay, selection. In this case it's best to do it on mesh, because if not you will always have a scaled selection that's based on your projection in your view of your monitor, and this is not following your size changes, so you are able in this case to directly mark on the triangles and select something. I think this is a really cool tool. So we are able to select like this. Maybe I'm just going to select just a little part of this what is overlapping here on the keyboard, and we are going to just delete that. You might have this problem that selecting in front some high curvature will make this unstable, so you are over Control Z. Going back, you can, in this area where you have highly multilateral curved area, you can just deselect with Control the area that is having that high curvature change, and try again. And this looks already much better. So I just do that step by step. And you see that this tool is really a reason to continue to work on this topic in Geomagic, and with a really low effort you are able to create a pretty cool result of a whole car, and it saves you actually a lot of time doing it like this. Why? Because you just have not even half of the work to do. You are let's say much faster regarding putting markers on the car. You are as well much faster regarding spraying. It is a huge save of time, and with an FreeScan UE you will be able to do that. So I will not continue work on this result because I will not use that scan. This is just a demonstrator. You can of course go here and repair what is missing. There is a bunch of cool features to post-process these areas, to close holes locally, to get rid of some residuals. This is another video, and I already started or made some of them in the past. This is not for now. I think we are fine so far with the result and the purpose that we did it for. And I think you can really see the benefit of using that scanner here.